Okay, so in this video I'm going to have a look at linear regression. So I'm going to have a look at two sets of data here, and I'm going to see is there a relationship between these two sets of data. We're going to plot these data on a graph. We're going to plot a scatter graph, and we're going to draw a line of best fit through the points. It's going to be a straight line. We're going to look at calculating the correlation coefficient and finding the equation of that straight line. So this is a question that came up in 2013 in the Leaving Certificate higher level paper. So let's have a look through it. The responses of 10 individual passengers to the questions on the age and in-flight spend are given below. So we have people who are 46 spent 30 euros, person who was 29 spent 15 euros, 37 spent 20 euros, someone who was 18 spent 0, and so on. So we're just going to plot all these first on a scatter plot. So I've actually done that already down here. So we have along the x-axis we have the age, and on the y-axis we have the spend. Now the age here is what's called the explanatory variable, and the spend then is what's called the response variable. So as people get older, would you expect the spend to go up? And it looks like it does here. It looks like there is a relationship between the two. So normally you would put the explanatory variable on the x-axis and the response variable, or the dependent variable, on the y-axis. So we have our points plotted here, and the next thing we're going to do is just calculate the correlation coefficient between the passenger age and in-flight spend. So the correlation coefficient is a number that will give us an idea of how strong the relationship is between the explanatory and the response variables. So normally your correlation coefficient is called OR, and it goes from -1 up to +1. So in other words, if your value for the correlation coefficient is 1 or close to 1, it's a strong or perfect positive correlation. So the graph will slope this way, and the points will be very close to that line. If it's -1, the slope will be the points will slope this way, and the points will be fairly close as well, or very close to the straight line. They will be very close to a kind of an average line, if you like. Now if you have points around the straight line this way that are not quite as close, you would say that the correlation is moderately positive, and you would be looking at a correlation coefficient of maybe 0.8, 0.85, 0.7, somewhere around there. If there's no correlation, then your graph will just simply, the points will more or less look something like this. There's no positive or negative pattern to the points. The slope of the points is not going this way or this way. So in this particular case, we can see that there's a positive correlation, in other words, it's sloped this way, and we can see that it's reasonably strong here. It's fairly strong. If we were to draw a line through this, the points would be fairly close to that line. So let's just calculate this correlation coefficient and see how strong the relationship is between the age and the average spend of passengers. So I'm going to do that using a calculator. I'm going to use this calculator here. I'm just going to put in these points, or these data points here. So the way I'm going to do this is, let me just move that over here. On our x-axis we have our age, and on the y-axis we have the spend. So let's just start. First thing you normally do with this type of calculator, now obviously you may have different types of calculators, but this is the one I'm going to use. First thing I would normally do here is just clear everything. So I would go Shift, press 9 here, and this allows you to clear your calculator, clear anything that might be in the memory and so on. So we're going to clear everything here, so I'm going to press 3 equals, we'll say yes, and then AC will bring me back again. Okay, so everything has been cleared from the calculator. So let's start then. The first thing we're going to do is just put our calculator into stat mode, statistics mode. So I just press mode here, and I'm going to just press 2 here for stat. So we have a number of options here, 1 variable or 2 variables. So this is a plus bx. This will allow me to put in 2 variables here, and we have 2 sets of data here. So I'm going to press 2 here, a plus bx, so that will give me a table here where I can put in x values and y values. So after that, I've just got to key these things in. So let me see what's the best way. Yeah, okay, so let me see. I'm going to put in 46 and 30. So, well, actually, I'll put in all these ones first down the x column, and then these ones here down the y column. So just bear with me while I just enter all of these. So let me see, 46, then press equals, 29, press equals, 37, equals, 18, 25, 75, 52, 35, 40, and 31. Okay, so I have all my x values entered. So now I'm just going to move up here again to the start, to number 1 here, and I'm going to put in my y values here. So I'm going to start with 30, 15, 20, 0, okay, 0 is already in there, 0, 10, 45, 25, 20, 20, and finally 30. Okay, so that's all the data in there. So next thing I can do is just press on, and my data should still be in there, hopefully anyway. Okay, so now I want to work out the correlation coefficient here. So what I'm going to do is use this stat mode down here, just over the number 1 here. So I'm going to go shift and 1. And what I'm doing here is regression. I'm doing linear regression. So this is reg here, number 7. So I'm going to press 7. And you can see there's an OR here. There are other things here that we can have a look at later, but we're going to have a look at OR first. OR is our correlation coefficient. So I'm going to press 3. So there's my OR, press equals, and I get 0.88, 0.88. So that's my correlation coefficient, 0.88. So let me just put that in down here. Calculate the correlation coefficient between the passenger age and in-flight spend. So that is 0.88. So that's a strong positive. It's positive. It's very strong here, close enough to 1. So that's a strong positive correlation. So in other words, what can I conclude from the completed scatter plot and correlation coefficient? Well, we can see there is a strong relationship here between age and the amount that people spend. So as you get older, you spend more. Your in-flight spend, if you like, is more. Okay, so next thing we're going to do here, we're asked to sketch a line of best fit in the completed scatter plot above. So let's have a look at doing that. Now I did this by hand. Obviously when you're doing it, you can use rulers and so on, so you'll have to bear with me here, but the way I'm going to plot the line of best fit here is to get the average of the x values and the average of the y values, the mean of the x values, the mean of the y values, plot that point, and then what you would do is put a ruler on that point, and after that you can do it by eye. Okay, now you can do it by eye without doing that, but it's just a little bit trickier. So let's have a look at, we'll go back to our calculator again. Now our calculator will actually give us the average of the x's, the mean of the x values and the mean of the y values again. So let's go here, shift and stat again, shift and number 1 here, which gives me stat here. So what I'm going to do here now is go to this option here, number 5, which is VAR, and you can see here you've got an X bar here and a Y bar. This will give me the average of the X's, this will give me the average of the Y's. So I'll just write these over here. So I have my X bar is equal to and my Y bar equal to. So let me just go back to my calculator again. So my X bar here is number 2, so I'm just going to press number 2 here, press equals, and that will give me 38.8. So that's somewhere around here. So X bar is 30, whoops, that's 38.8, and my Y value then, just cancel that again, shift, you have to keep going back into this again, go to 5 VAR, and you see Y bar here, so let's press that, that's number 5, and that will give me the average of my Y, so that's 21.5. So I'll put that in here, 21.5. So I'm going to plot this point here. I'm going to plot the point 38.8, 21.5, this point here. So let me just do that. I'll do that in different color here. So 38.8 is going to be somewhere around here, and 21.5 is going to be somewhere around here. So this is my average point, if you like, my mean point. So what you would do is put your ruler on this, and then all you've got to do is rotate your ruler around that. Whereas if you didn't have this point, you'd have to move it in 2 directions. So put your ruler on here and draw a line of best fit through this. You're doing this by eye now, so again you'll just have to kind of bear with me here. So it's going to come up along here like this. Whoops, it's going to go through that point and up along here. Something along those lines anyway. Okay. So that's my line of best fit. Now from this, we're going to look at finding the equation of this line here. Now in order to find the equation of a straight line, really what you've got to do is find the slope of the line and put it into the equation of a straight line formula, if you like. Yeah. So what we're going to do here really is use this formula here. Y minus y1 is equal to m into x minus x1. Now in order to use this formula here, we need a slope and we need a point. So we have points that we can pick on this line. I could use this one. We can, let's say this point here is on that line. It's just slightly off it, but depends on how you draw it here. So I'm going to use this point here, and maybe this one here as well. Well, actually I know this point is on the line, but there are any number of points you can pick along here, but you must pick points that are on this line here. So the first thing we've got to do is find the slope of this line. So I'm going to do that first. So our slope formula is just y2 minus y1 over x2 minus x1. So I've got to find 2 points on this line. So let's pick 2 points that are far apart. This one here looks good. I'm going to pick this point here, which is on the line. So that is 65 on my x. So that's 65, and the y value here is 50. Let's pick another point. Well, let's pick this one here. This is 25 and 10. 25, 10. Okay, both those points are on the line. So I'm going to say this is x1, y1, this is x2, y2. Stick them into this formula here and get our slope. So let's see, we have y2, which is 50 minus 10 over x2 minus x1, so that's 65 minus 25. So that should give me 40 on the top. Let me just work out the slope here as well. So we have 40 on the top, and 65, 55, 45 on the bottom. So we have 40 divided by 45, or just 8 over 9. 8 over 9. So that's our slope here. Now we just got to put that into this formula and work out the equation of our straight line then. So we have y minus, now I'm going to use one of these points as a point on the line, so I'm going to put that in here. So let's use this one here, our x1, y1, 25 and 10. So we have, let's see, y1 here is 10, so I'm going to put 10 in here, and that's equal to our slope, which is 8 over 9 times x minus x1 here, which is 25. Okay, so let's just work this out. Multiply across by 9 here, and we get 9y minus 90 is equal to 8x, and then we've got 8 times 25 here, which is 200. So let's see, did I do that right? 9y minus 90, and then we have 8x minus 200. Okay, perfect. Now the way I'm going to write this, the equation of this line, is in the form y is equal to mx plus c. So I'm just going to get the y on its own. So we have 9y here is equal to 8x, and we have minus 200. We have minus 200 plus 90, so that's minus 110 here. Next thing I'm going to do is just divide across by 9, so finally we get y is equal to 8 over 9, which is what we'd expect because that was our slope, x minus 110 over 9. Let me just see if we can do anything with that. No, we'll just leave that as well, we can put it as 12.2, or we'll leave it as 12.2. So this is the equation of this straight line here. Now this is the equation of this straight line here. So using this you can maybe predict certain values. Okay, so let's have a look then at how your calculator can be used to kind of generate this equation here. So we go back to our calculator again here. Now let's just clear this again. So if we go shift and 1 again, so we're back here again at our stat mode. So let's have a look at number oh no, it's actually, let me just go back again, shift 1 and 7. Yeah, so what I did there was shift 1, and we're going into regression again, number 7 here. And you can see we've got an A and a B here. So if we just look at those values, let me just write those down here. First of all, I'm going to write down A is equal to, and I'm going to write down B is equal to here. Okay, so let's have a look at those two values. Let's have a look at A first. A is 1, and what did we get there? Minus 4.54. So that's quite a bit out, but anyway, we got minus 4.54, and then we have here, let's start again, here we go, shift 1 again, whoops, shift 1, and we're going to go look at 7 here again, and we're going to look at B here, which is number 2, press equals, and we get 0.6713, 0.67, let's say. Now these really are these values here, your slope and your y-intercept here, if you like. So what we can do with these is, from the data that I've typed into the calculator, so the data is in the calculator, your calculator will calculate this value here and this value here for you. So you don't have to go through this process here if you don't want to. You can use your calculator. Now, because I drew this myself by eye, these values are different, slightly different to these. In this case, quite a bit different. but the slope is not too far away. So the slope of this line here is b. So the equation of the straight line from my calculator's point of view would be y is equal to 0.67 x minus 4.54. So this is what my calculator would have calculated as the equation of the line of best fit through these particular points. Because I drew this by eye, it's going to be off slightly. So doing it manually, you get this equation of the line. Doing it from your calculator's point of view, which will give you the best line of best fit, if you like, this is the equation of the best line of best fit. So A here is minus 4.54, I got minus 12.2, so there's quite a bit of a difference there, but that's based on this particular line. This here would be the y-intercept based on this particular line. The calculator would have calculated it a lot more accurately, and they would have had a y-intercept of minus 4.54. The slope here is 8/9, which is actually 0.9. I got 0.7, or the calculator got 0.7 here, so it's not too far away. Okay, so that's it really for linear regression in this video.